Alright, this should be good, so let's go for it. So today what I'm going to do is just go over and review what I made. So I did a practice problem generator. The quote-unquote code that runs it is over on this side. Oh, why is it? Oh, because that doesn't count. Code is over here. It goes from simple things like 7 plus what number will give you a -5. Of course, you want to get the variable you're solving for by itself. So you undo a +7 with a -7, and you put that on both sides, and you'll get -12. So 7 plus a -12 will give us a -5. For those that negative numbers are taught technically in elementary school towards 4th and 5th grade. Well, because at one point I described this as an elementary school thing. Anyway, again, code that runs it is over here. It just uses the ran between and some if-then statements to change things up. So, clearly go over it over there. So let's get to it. So anyway, previously, I did a few of these, and I was like, I can do a better job. So I'm going to do a better job. So I originally talked about this in terms of how you can think of all of the different positions of whether it's operations or exponents, numerators, denominators, how those can all combine to create different versions or permutations and combinations, where order matters and then it don't matter. So, yeah, and how you could get, depending on what's in the denominator and other issues, different types of problems, as in problems where there is no solution, and beyond that where you can't even conceive it. So speaking of fractions, a lot of people keep asking me to talk about fractions or discuss them or just have a little tutorial on them. So I will do that actually right this moment to just do right. So let's keep this super simple. Numerator is on the top. Okay, good. I wasn't off camera. Denominator is on the bottom. So I usually teach this in the context of probability, and probability is a great way of thinking about this. Also, if you notice, this is a fraction bar or a division bar. And what you are, again, if you think about this in terms of probability, is there's what you want, over what's possible. I think about this in a few different ways. So let's say you want one number out of 4. So when you see the words out of, think division, think fractions. So 1/4 out of 4 quarters, or $1, does they give you your 25 cents. You can also think of this as equally divided. Oh God, I am tired. And I have an interesting writing style. I can clean it up a little bit. So anyway, equally divided among possibilities. Now among like 100, if you want to think of percent. So 1 point out of a total 4. So yeah, out of total possibilities, because you are dividing 1 by 4. Okay, so moving on forward. Numerator, denominator, what you want, what's possible. You want one number out of 4. You want 1 out of 10. Just the easiest way I can think about it. To give a practical example, because people be like, when will I ever use this in real life? My favorite. Yeah, I'll finish that. Obedience. And you have sacrifice. So in the word it says obedience is greater or better than sacrifice. Alright, so if everything is sacrificed, then there's nothing left. So it's better to be overly obedient than it is to lose everything because you were disobedient and you screwed it all up and wasted it all away. You can have fun with the mechanical man piece in terms of obedience and freedom, but again, there are always consequences. So just make sure those consequences or those outcomes are going to be what you want. So again, whether this is obedience, whether this is what did I say, like freedom, and then you have like authoritarianism. You have all different types of things that you can think about this. Skill, what is it? Skill and technique versus power. But again, just discussing different ways of balancing stuff. Good stuff. I don't think there's anything else that I need to go over. Of course, if you have questions, you can ask me in the chat or whatever comments that you do want to make. But again, fractions are easiest understood in the context, to my knowledge or in my experience, of probability. So for instance, if I had students sitting in a column, then I'd be like, hey, I've got this eraser, or I have this pen, or I have a piece of candy. If I'm throwing it, what's my chances of hitting a student if I'm going to throw it at a desk? So this gives us, the opportunity for the kids to think about, all right, we want a student to get the candy, and what's possible since he's throwing it at a desk. Come on, are you not? Thank you. Excuse me. Because using the desk as a reference point. No students are sitting on the floor in this example. Alright, so if it is, let's say, 5 or 6 deep, you got 6 desks, and then let's say it's 1 kid, so you have 5 out of 6, and of course, I would always tell them to consider the teeter-totter. So, clockwise, which is where I got my 8 from, so I was already thinking. Okay, so kind of like 83% chance. So anyway, hopefully that'll make sense. I'm gonna keep pushing and move on to what I'm actually supposed to be doing, which is showing the practice problem generator. So again, if you take an empty cell Oh, yeah, I'm not doing one of those. Because that's just way too unnecessary. But why not do one of these little monsters? Okay, so it's gonna be interesting. Is this 2? No, it's just 1. Alright, well, all you can do really is solve one in terms of the other, because we've got 2 variables within one equation, so that's gonna be problematic. So, let's keep it. That's just gonna be too simple, even though we'll end up with a bigger number. Is there 2 over here? Of course you can zoom out. I do give descriptions of what they are and what they're doing. Alright, so in this one is single variable equations. There are 4 terms. So 1, 2, 3, 4. Operation 1.1 can be addition, subtraction, or multiplication. And then, oh yeah, I forget, I haven't downloaded this one yet, so I would have to like delete this, or I can just hit delete. So let me change this now. Okay, so again, just take an empty cell. You can press delete. You know, I'll just let this do for that. I'm not really, it doesn't matter. I'm whatever the situation calls for. So, you know what? I am going to do this one. Start on black. Alright, so right now, actually we already look up and get one of these to be eliminated off the rip. Anything to the 0 power is 1. What about 0 over 0? What does that equal? I mean, you got 0 in the denominator, but what if you did that? Does that change it? Because anything to the 0 power is 1. Is this 1 or is this 0? Anyway, moving on forward over here. So what we're really going to end up with is 4/3 is y. Speaking of which, let's go on and talk about this. You are, of course, aware of the PEMDAS. So for instance, if you go this way, you're usually solving for y. Or you are, what is the easiest way? It's like you're going from the outside in. Is that the right way to think about it? Outside in versus inside out. This is what I get for trying to do too many things at a time. So anyway, with elimination already done, then what we really got now is 3y equals 4, and you undo multiply by 3 with divide by 3, which is why I said y is 4/3 or 1 and 1/3. You can now plug this into that up there, and you can have negative 1 y minus 3x equals 2 negative 1 Okay, so undo positive, undo a negative with a positive. So at this point you can have all of the fun, and you can make this 6/3. Because so moving on. 3 1/3 negative 3x equals 3 1/3. So I think we know where this is going. Other than to trifle in this. So let's, Lord, because that's really 3 plus. So I wonder, would that be 10? No, that doesn't make any sense. Good old fun in my noggin. So let's put this back to the 10/3. Which is really 3/1. So remember, we flip. So yeah. I'm having what I've been thinking about as I've been doing that is this the way of thinking about 10/9, or specifically 1 with or combined with the fraction of 1/9, because this is 1 plus 1/9, which makes me then think about what, when we were over here, if this is really 3 plus 1/3, and that is being multiplied times a -3. Make sure that I didn't, yep, that's what I thought. I was like, not be screwing up and forgetting stuff. Then that will be distributed out. Which is why I thought 10. Because that's funny. Because it's definitely not multiplication right there. But I don't think you do that, because it's not 10. Or is it 10? Yeah, because even if you look at it in general, you have a number that's slightly bigger, so you should get something that's a little bit over 1, which is why this is ringing more true than this. What I did was just looked at these as total values. So whatever this is again a little bit over 3 because the fraction isn't that big. Anyway, this is what happens when you overthink stuff. I don't think I want to do anything else with this because I want to do something else on my Christmas Eve, but hopefully, oh, let me check these. So we've got 2 fractions as our final answer. We have x equaling 10 over 9 negative, and then we have y equaling 4 over 3, and that being positive. So what we haven't checked is the 4/3 and the 10 in the top. So let's look and see what happens. If we have a negative 4 over 3, and we subtract that from 3 times 10 over 9, does that equal 2? So, already looking interesting. But again, a negative 4 over 3, and here. Okay, no, that may not be so bad, because that's going to simplify to a third, because 3 over 9 is a third, and then that's still the negative 10 over 3. So I think we're looking pretty good, because to convert this over to a fraction, we're looking for the least common denominator, which is going to be 12 in this case, so we're going to have 12 negative over 3 minus negative 10 over 3. So that I'll do that down here. That's going to end up being positive. Oh, that actually does work. No, dang it, that doesn't, because now I have a negative. Fart. I hate when this kind of stuff happens, because it means that I made a mistake somewhere. Negative, negative, negative. That's fine. I wonder, is that a problem? Because that was like negative, and so technically I should have made that. So this should be negative. Even if that's negative, then that makes this positive, which changes all of that, because that changes that over there. That's right. I can do that with that. That turned out fine. 3/3. That's all positive. Oh, I was like, what did that? Because those terms weren't like negative 3x. That's fine. Negative. Negative. Yeah. No, kept my negative. That all checks out. Seems right. Oh, whatever. I'll deal with this in a hot second, because right now I'm getting negative 2 equals positive 2, and I know that's not correct. So anyway, that's going to just change to plus, and negative 12. And that's not right even for that. Good fun stuff. Oh, yeah, let's do that right. Okay, thank you. System of 2. Oh, thank you. All right. Negative 1y minus 3x equal. Oh, god dang it. Three y negative ox4. 3y negative ox. So then, no, that is right. So where did I make this little goof? Oh, that would be because it's 4/3 and that needs to be 9. Oh, okay. All right. So they get being too fast. Because I was like, this isn't making the sense. And it has to make the sense. So to get this to... Okay, good. My default is to just assume that I screwed up big time. Alright, let's go back, which I did technically. So, negative 4/3. Oh no, actually I could have kept that. Negative 4/3. Again, this is going to be negative 10/3. So we're already where we need to be. That's what I did wrong. So negative 4/3 is going to make that plus 10/3. 2. This is the smaller number, so it keeps the sign of the larger number. Okay, now this is making the sense. Because I was like, this is what happens when you sometimes thinking all of the steps ahead and not focused in the moment. So yeah, so we're good. Wolfram Alpha says we're good. So we is the good. Negative 10/9. Negative 10/9. Y is 4/3. Y is 4/3. So again, just to talk about the whole PEMDAS versus SADMEP. If you're going this way, then you're usually solving for x, and it's inside out. Actually, I think I might have that a little bit backwards. Actually, it still kind of depends. So, like, for instance... Oh, God. I don't feel like doing this. And yet here I am. Just making this up. So, like, if somebody gives you... then you're going to start putting these in, doing the PEMDAS. If somebody asks you to solve for x, then you're going to start from the outside and moving this stuff over here, because you cannot affect these yet, because you have this addition and subtraction here. So this is also where you would technically divide by 2 if you wanted to complete the square and all of that other stuff. But I'm not doing that because that's not what this is about today. I'm just demonstrating this. So again, what I wanted to simply talk about today was the fractions. So again, numerator, denominator, what you want is at the top, what's possible is at the bottom. 1 out of 4, you just want 1 out of the 4 equal parts. So you want 25% or you want a quarter. So again, equally divided among the possibilities. If you're talking about percentages, you're dealing with 100. Otherwise, fraction-wise, you're just dealing with the number 1. So again, practical applications of it is the Bruce Lee thing. You know, you don't want to be all technique, the mechanical man, and you don't want to be all instinct. Okay, I thought that this was... Okay, maybe it is overheating. It may be overheating. So let me hurry up. I don't think it's overheating. So you don't want to be animalistic in all fury. Obedience is better than sacrifice, I assure you, in every possible way. You do not want to, and it's like F around and find out. It's all of these things are just all about balance. So freedom, authoritarianism. So again, using the example of students sitting in a classroom, you got 5 desks that make up a column. 6 desks that make up a column. 5 students sitting down. And so the possibilities, if I'm throwing candy at a desk and I'm going to hit a desk, that's the only possibility. This is how this stuff plays in. Is 5 students sitting there, and there's 5 out of 6 chance. That is approximately 83 per percentage. So I'm done. The next thing we did, actually completed the problem. I put out this beautiful conundrum to you. Anything to the 0 power is 1. You can't have 0 in the denominator. What if you put 0 to the 0 in the denominator? Does that work? And then what if you put 0 to the 0 power over 0 to the 0 power? And then if you really wanted to be a jerk, put all of that to the 0 power. And is that 1? So we used elimination. It was already done. We could have done substitution, which is what we eventually did, because since we had this, we just put that y value up here, and we came out with negative 10 over 9 and for x and 4 over 3 for y. So we checked it, we did it. I had made an error when I was thinking about the GCF, because I was interpreting this as going to be, I was thinking that we had to give it that be 9, which would have put us 12 over 9, so that's where the 12 came from, because 3 times 3 and then 4 times 3, to get it to a common denominator. But that was unnecessary, because when we simplified this 3 times 10 over 9, that was negative. This is 3 over a 3 times 3, and anything over itself cancels out with 1 3 left down in the denominator. So yeah, that's it. Did a little bit more in terms of, again, I was gonna say, what is it? I was thinking exacerbated and then exasperating, which math is further expanding upon this whole PEMDAS thing versus SADMEP. And again, working, it's like over here, there was no addition and subtraction that we could do. We had to do multiplication and division first, because there were no parentheses or exponents, unless you want to consider those parentheses right here. But that's what we did, and then at the end we were able to do the addition and subtraction. And I know that's funny, I'm saying solving for y even though we were solving for x, but hopefully you get what my point is. And if not, what I can do is this beauty right here. It's gonna be like adaptive history. And I need to go and buy some. And then that's going to be a problem too, because in a normal thing, again, from over here, that is actually what you're doing. You have to do the addition and subtraction first when you're solving for the x, but whatever. Hopefully you understand what I mean by SADMEP versus PEMDAS. And like I said, I gave an example. And I'm going to let that do it because it's 5 o'clock and this is my break day. So use your powers. Use your powers for good. Do good things. Stay awesome. Stay blessed. Do the right thing. Do your best. Merry Christmas.